This video tutorial will cover the GVC I can solve mathematical problems using numerical and algebraic expressions and equations. The specific learning target we're focusing on is one-step equations, namely I can solve and interpret equations using properties, like terms, and factoring for one-step equations. So we're going to go over some vocabulary to make sure you understand it. A lot of this will be review from what you've learned in video tutorials past. So you'll need to know what an equation is. An example of an equation might be like 2x plus 3 is equal to 10. This is different than an expression. We'll talk about this in the next slide, but an expression might just be 2x plus 3. The difference between them is one has an equation sign and one does not. So expression, equation. All right. Additive inverse is going to be something you have to understand. Additive inverse is just a fancy way of saying the opposite of either addition or subtraction. For example, negative 5. The opposite of negative 5 is plus 5. If I do a number plus its opposite, I will always get a 0 pair. So I always get 0. That's a 0 pair. So any number plus its opposite will always equal, that's supposed to be a supposed to be an A, plus its opposite will always equal 0. So additive inverse, 0 pair, that's important to understand. Okay, a variable, a lot of people already know this, but if you have a term like 5m, the variable is your unknown. Okay. The coefficient is the number next to the variable. So 5 would be the coefficient, m would be the variable. A constant is a number excuse me, is a number without a variable. So plus 7, minus 7, any number without a variable is a constant. And a term in this, so in an expression, this expression here, there are two terms. This is a term and this is a term. There's two terms here. And then a solution, now that we start dealing with equations with equal signs, a solution would be to find the actual answer for m, so solve for m. Okay. So again, this is just going to kind of show you the difference between an equation and expression. So this is what you've learned before. So far, you've learned how to simplify expressions. Simplify expressions. So I'd give you something like this, and you would use distribution, and then combining like terms. You'd use combining like terms to be able to simplify the expression, but you were never able to solve for the variable. We'd never know what x is equal to. Now, we're actually to a point where down here, we can take this expression and put one thing on it, make it an equation with an equal sign. Now that I know what that whole expression is equal to, if it's equal to 32, then there is a solution for x that we can actually find, given this extra piece of information. So let's just dive right in and start showing you how to apply the additive inverse to solve for the variable. We'll start with something really easy. The temptation is that kids look at this and go, okay, some number plus 10 is equal to 18. Well, g has to be equal to 8. And that's great. If you can do that in your head, that's awesome. But we also want to show you how to use the additive inverse property so that you can solve for equations on things that are a little more difficult to do in your head. So here's the point. You have to identify the variable, which is g, and then you have to identify all the things around the variable, like this constant here. I want to get rid of this constant. The whole point to solve for equations is to get rid of the numbers around the variable. We call it isolating the variable. How do I get rid of a 10? Well, I apply the additive inverse. What number do I put on this side of the equation that will get rid of a positive 10? The only number I can use is putting a negative 10 on this side. Here's the thing about equations. They're supposed to be equal to each other. That equal sign means that the left side is equal to the right side. And so in equations, if I'm trying to isolate the variable, I start doing things to this side of the equation to get rid of the positive 10 here. So I put a negative 10 on this side. Well, once I put something on one side of the equation, so now I've actually got g plus 10 minus 10. Now that I have that on this side of the equation, is this still equal to 18? The answer is actually no. It's now unbalanced. So what do I have to do? Whatever I do to one side of the equation, I have to do the same thing to the other side. So if I subtract 10 from this side, to keep it equal, balanced, I have to subtract 10 from this side as well. So now, to make this equal, it would be 18 minus 10. Okay, so now, here's what you got. You have g plus 10 minus 10 is equal to 18 minus 10. I've kept the equation equal by putting a negative 10 on both sides. I know you're looking at this and you're thinking, Mr. Stewart, this is way too complicated. You're making something super easy into something really complex. But I'm showing you this so that you can understand it. What's 10 minus 10? Well, that's a zero pair. So that's the additive inverse made that go away. So we have g is equal to 18 minus 10, which of course you already knew was 8. Let's look at another example. I won't explain it this time, but I'll ask you to try these, and then we'll go ahead and do this. So go ahead and try to solve this. Okay, if you're applying the additive inverse, my variable is h. The number that's with the variable is a positive 5. So I'm going to try to get rid of this positive 5. How do I get rid of a positive 5? I use what we call the additive inverse. What's the additive inverse of a positive 5? What's the number that makes 5 go to 0, which would be a negative 5? So I put a negative 5 on this side. But if I put a negative 5 on one side, I have to put a negative 5 to the other side. So I'll just rewrite this. I've got h plus 5 minus 5 is still equal to 3 minus 5. So what happens here? That's a zero pair. Right, the additive inverse makes these go away. So I'm left with h is equal to, what's 3 minus 5? That's going to be negative 2. So my answer is negative 2. All right, let's try this next one here. Go ahead and try it on your own. Okay, let's check this. So this is a little different than the first two examples. Here's my variable m. But this time, what do I have? I have a negative 6 here, or a minus 6, if you want to think of it that way. And this minus 6, I have to get rid of this minus 6 to solve for the equation so that I know what m is equal to. And so I have to apply the additive inverse. What's the additive inverse of negative 6? That would be a positive 6. Whatever I do to one side of the equation, I have to keep it balanced by doing the same thing to the other side of the equation. So what I have is m minus 6 plus 6 is equal to 10, my original, plus 6, the thing I added to both sides. So I added this side and this side to it to keep it balanced. Okay? Now what happens right here? That's what we call a zero pair. Negative 6 plus 6 just goes to 0. So I'm left with m is equal to 10 plus 6. 10 plus 6 is 16. And I'm done. Okay, a few more examples. Go ahead and try this one on your own. Okay, so now we've got a variable over here. This is a positive t. And what do I have with it? I've got this negative 3 here. I've got to get rid of this negative 3 from the t. I've got to isolate the variable t. To isolate it, I focus on the numbers that are with the variable. So what's the additive inverse of negative 3? What's the opposite of negative 3? How do I get 3 to 0? I add 3. Whatever I do to one side, I have to do to the other. So I add 3 to this side. So basically what I have here is negative 3 plus 3 plus t is equal to 5 plus 3. So in this case, I've got a zero pair here that goes to 0, so that those go to 0, and I have a positive t here, so I'll put t is equal to, well, what's 5 plus 3? 5, 6, 7, and 8. All right, go ahead and try this one on your own. Okay, so the variable is on the right side. Does this cause problems for us? Do we handle this any differently? The answer, of course, is no. We can still handle it all the same. So here's my variable on the right. It's a positive u. I've also got a negative 8. So that's what I need to get rid of, is this negative 8. I want this variable u to be alone. So what is the inverse, what's the, the inverse operation, additive inverse of negative 8? It is a positive 8, right? Those are 0 pairs. If I put positive 8 on one side, to keep the equation equal, I have to put a positive 8 to the other side. So I'm left with, let's see, I would write this. Negative 8 plus 8 plus u is equal to, we've got negative 13 plus 8 here. Right, so I've got the 8s here that I added to both sides. So this is a 0 pair. The inverse operation makes things go away. So that goes to 0. I'm left with u on the right side. And on the left, I just have to combine these two. So negative 13 plus 8, that should be a negative 5. Right? 9, 10, 11, 12, 13. Yep. So there you go. All right, just I think 2 more examples. Go ahead and try this on your own. All right, so here's where things get a little bit more helpful to use the inverse operation idea, or the additive inverses, is because sometimes doing decimals in your head, it can be a little bit tricky. So here's my variable g, and I want to get rid of this positive 4.6. What's the inverse operation? What's the inverse of a positive 4.6? What's going to get rid of this positive 4.6? Well, it's a negative 4.6. And then, of course, if I put negative 4.6 on one side to keep it equal to the equation equal, I have to put a negative 4.6 to this side. Okay. Now I'm going to rewrite this. So I've got 4.6 minus 4.6 plus g, oh, running out of room, is equal to 2.25 minus 4.6. So this is not mathematically too difficult for us, especially if we have a calculator. We know what happens there. Those are 0 pairs, so inverse operation always makes those numbers go away for us, which is nice. I'm left with g is equal to, let's see, 2.25 minus 4.6. I'm just going to type that in my calculator, 2.25 minus 4.6, and I have a negative 2.35. And that is my answer. This is the solution for this equation. G is equal to negative 2.35. Last example, so we're going to do some fractions. So here's k. It's a positive. Here's the constant, 1/2. And I'd like to know, what do I have to add to 1/2 to equal 1/5? What number plus 1/2 equals 1/5? So how do I get rid of a 1/2? I want to isolate the variable k. How do I get rid of that 1/2? Well, I apply the inverse operation, which is additive inverse of addition subtraction. So what's the opposite of a positive 1/2? It's a negative 1/2. To keep things equal or balanced, I have to do a negative 1/2 to this side. So what I have essentially is 1/2 minus 1/2 plus k. And that is equal to 1/5 minus 1/2. So what happens when I do 1/2 minus 1/2? That goes to 0. So I'm left with k is equal to, what is 1/5 minus 1/2? To save time, I'll just do this in my calculator. 1/5 minus 1/2. Actually, I probably could have done this in my head faster, but that's okay. And that equals negative 3/10. So my answer here is negative 3/10. This is a good example of an equation that would have been more challenging to do by guess and check or trial and error, or by just looking at it and thinking of the number. So this is why the additive inverse, the inverse operation idea, works really well with solving for equations. Hopefully this is helpful. Have a good day.